Welcome to this edition of Times Techies Friday Plus Plus. I'm Sujit John, and I have with me my colleague Shilpa Fadnis. The two of us will moderate this discussion. This is the third in our series on electronics and semiconductors that we are doing in partnership with Siemens EDA. In the first session, we discussed how everything around us is becoming intelligent and how our lives are being transformed by electronics. In the second session, we discussed how edge computing is becoming the centerpiece of everything, from autonomous cars and home automation to industrial IoT. Today, we'll discuss how to develop and skill the workforce necessary for the semiconductors and electronics boom in India. The government has in the past couple of years announced some path-breaking policies around electronics and semiconductors, including the PLI schemes and the policy to build a comprehensive semiconductor ecosystem, including a fab. How do we develop top talent to support research, design, and manufacturing? It'll require the government, industry, and academia all playing crucial roles. To discuss that, we have three distinguished professionals with us today. We have with us Sunita Verma. Sunita is Senior Director in the Union Ministry of Electronics and Information Technology. Sunita graduated in Computer Science Engineering and joined the ministry in 1990. She has been playing a crucial role in evolving the R&D base in various areas of electronics, including microelectronics, nanotechnology, system design, medical electronics, and high-performance computing. She was closely associated with the implementation of the Special Manpower Development Program at academic institutions that has helped the country gain VLSI design share globally. Sunita contributed to the promotion of the fabless industry, which resulted in formulation of the National Policy in Electronics 2019. That effort recently concluded in the announcement of the Chips to Startup program to be implemented by 100 academic institutions and the design-linked incentive scheme to nurture 100 startups and MSMEs. Welcome, Sunita.
Thank you. Thank you.
We have with us Dr. Anand Baria. Anand is Senior Vice President of Engineering at OpenFi. OpenFi builds customized silicon solutions, differentiated IP. He oversees all engineering for the company's ASIC business unit. Prior to OpenFi, Anand established and oversaw the India operations of NetLogic Microsystems. He has over 32 years of industry experience, having begun his career at National Semiconductors Fairchild Research Center in Santa Clara, California, where he worked in advanced CMOS system process development. He holds a PhD from Stanford University and a BTech from IIT Bombay. Welcome, Anand.
Thank you.
And we have with us Ruchir Dixit. Ruchir has been on the platform before. He's the country manager at Siemens EDA. Ruchir came to Siemens when Siemens acquired Mentor Graphics. So he's been with Mentor Graphics for practically 22 years now. For about half of that period, he was in the US. He's also the treasurer and executive council member at IESA, the India Electronics and Semiconductor Association. In all these years, Ruchir has been directly worked on or worked with customers on over 200 IC tapeouts. After spending close to 10 years in IC development roles, Ruchir moved to EDA. In these roles, he worked with many customers worldwide and helped them to define the problem and the work to create solutions. Welcome, Ruchir.
Thank you so much, Shilpa. Thank you so much, Sujit. What a pleasure it is to be in the company of such guests. I'm sure that I am going to get an opportunity to learn from Anand and Sunita. And Sujit and Shilpa, thank you. Two of the few journalists who cover our electronics industry and actually understand the industry. So it's a pleasure to be here.
Thank you, Ruchir.
Pleasure as well, Ruchir. Yeah. Those of you doing this can send questions through the comment section. Sujit and I will put them to Sunita, Anand, and Ruchir. Let me start with you, Sunita. You've announced major policies for electronics and semiconductors. We hear that electronics manufacturing has already received a big commitment from global players. The same is now expected in semiconductors. What is your understanding of skills in this segment? There is a huge demand-supply gap. Can you share your thoughts on this, please?
Yeah, right. So to start with, yes, globally, if we see there is a value chain there where we have the design, the manufacturing, and the ATMT. And we had been concentrating on VLSI design for the last 20 years since this is the easier segment to address. There are design houses, multinationals, which have come to India globally. Also, the VLSI designers ones who are paid the most, you can say, and with an EDA tool and some experts, it is easy to set up the design centers or design houses. So with that, I think we had started with the semiconductor initiative and the capacity building since last 20 years from the Special Manpower Development Program, where we have been emphasizing on the skill development at BTech, MTech, and PhD levels in the VLSI area. And this is not just a training of 1 year or half a day training or 6 months training. It is through giving them R&D projects where the faculty of the colleges as well as the students, they come together and take up a design right from the specifications up to the fabrication. They get the opportunity to design with the state-of-the-art EDA tools. All the mentor graphic, mentor cadence and synopsis, all the tools are given to them. They can choose any of them. They are given exposure to that. Along with it, they are given the opportunity to fabricate the designs. And then when it comes back, test it and make a board and publish or take an IP of it. So this has been there, but then still, because we are in the 4th phase, so you can see that we are never able to complete the demand. So whatever the demand is there, whatever we are creating, and that is just not enough. And also, I feel that since we have the major design houses here, so we have been, that itself shows that they have a trust in us and we are able to supply to them the manpower that they require. But again, having said that, now that our government has announced the 76,000 crore major scheme for the semiconductor ecosystem for initiatives in all the segments of the value chain, we'll be needing more of the specialized manpower in all these segments, not only in design, but also in manufacturing, also in equipment, and also at all levels. It has to be researchers at the top level, scholars, and then maybe some generic BTechs and MTechs who are very fresh from college and can be trained in any area, right up to the technicians, the ones who have to handle the equipment or sophisticated tools. So that I think needs to be done, and government is taking out schemes for that also, and we are looking forward to academic, industry, and government collaborations to come out with such schemes where we can together work and this requirement, because expertise doesn't grow overnight. It has to be nurtured, and so is the skills.
Since I will come back to you on details about the kind of programs that the government is doing on this side. But before that, Anand, you've been in the industry a very long time. You've seen the US, how things are there. You've seen India for many years now. Where do you, and now with the government announcing these policies, where do you think the biggest gaps are?
I think in India, we are very fortunate on the supply side. When you look at human resources, we have an extraordinary level of supply with the demographics that we enjoy as a country. A lot of young people aggregated in institutions. So on the supply side, we have a great promise. The challenge for us is to convert that into talent, to convert the raw material into talent. And that's where the whole challenge is. As Sunita mentioned, there's a lot of good work that the government is doing. It's a lot of the programs are at the BTech and postgraduate level in R&D, and that is really paying dividends for us. What we need to do now is to vocationalize the whole semiconductor and silicon sector. And by vocationalize, I mean go into non-formal programs. A lot of the thing about the semiconductor industry is that it requires a whole spectrum of skills. It requires on the very leading edge, you need people with with architecting capability, who can architect systems, who can architect chips. You need people with PhDs and advanced degrees who've done a lot of research and then can contribute to the industry. And at the other end of the spectrum, we have a lot of what I would consider trade level skills that we require. They're very complex skills. They're not easy to acquire, and therefore they're very valuable. but they're still sort of almost vocational level skills. So, in things like, for example, IC layout, that's an example of a fairly vocationalized skill.
IC layout.
And then if you look, yes, and if you look at, as the fabs come online, as manufacturing starts here, we will need to create programs that are outside of the standard engineering colleges, and not only in institutions, but even outside institutions. So for any people interested in getting a foothold in the burgeoning industry, we need to have informal programs. For example, CDAC runs programs, 6-month programs that are skill oriented. Those kind of programs need to be expanded a lot more. So even within the chip design sector, there is a need for this entire spectrum of skills. And therefore, there's a lot of opportunity in skilling across the spectrum, both at the high end as well as at what I would consider the vocational end of skilling. And I think that's where we need to be very actively beginning programs for what's to come in the next few years.
Okay, wide spectrum. Ruchir, you want to add to that?
I think Sunita and Anand have really hit it on the head, right? But I would like to go back and try and understand. My favorite question always is not the what and how, it's the why. That's always been my favorite question. So why are we talking about skilling and a shortage of skilling or upskilling today? And I think that is because we have this privilege of participating and living in the times where we are seeing a real transformation. Sujit, when you started this session, you talked about electronics being around us everywhere. Edge devices are being around us everywhere, which means that we are seeing electronics getting into our lives and becoming ubiquitous. Wherever we look, there is an electronic device around us. And with this need for electronics, there is a need for people who can build the electronics. So that's what's causing this huge shortage, which we did not see maybe even 5 years ago, 7 years ago. Suddenly we see a huge sharp increase in the demand and what we can supply to satisfy the demand. Anand used the word supply, and I really like that we have no shortage of engineers. Let's not say that we don't produce enough engineers. We have enough engineering colleges, we have enough programs, we have enough people graduating out of those engineering colleges. The thing that Anand also talked about was, how do we make these engineers deployable in the industry, number one. Number two, make them deployable sooner. Because in my company and the companies that I have talked to, I'm sure Anand would agree that when we take a fresh college graduate today, it takes us anywhere from 6 months to 12 months to bring that person to a level where the person becomes net positive.
Yeah.
To the company. A lot of training that needs to be given to the individual, and this is across the industry, across companies. So let's teach them skills, like Anand said. Let's teach them how to solve real world problems. Of course, the curriculum that we have today is a very strong curriculum on the theory behind it, all the electronics, and all of that needs to be taught. All of that needs to be learned. Let's start augmenting that with actual skills that can be deployed on the jobs. Second part, I'm going to go beyond the industry that I represent, which is semiconductors. Every semiconductor needs to be placed in a system. That happens in a factory. Where does the manpower in the factory come from? Now, the same manpower factory can also be a chip fabrication facility or an ATMP facility. There's going to be a huge demand for that. And where are the places to train them, skill them? That's the polytechnics, that's the ITIs. So while we look at the glamour end of semiconductor, which is the IC design and all the things that come with it, there is this whole bottom of the pyramid that we will need to take us to where we want to go.
That's the vocational studies that Anand was talking about, right?
You have to ask Anand, but I think Anand was using vocational as a more applied part of the studies than just the technician part of the vocation.
Yeah, I think it's both. I mean, vocationalization is what is, I would say, the need of the hour. So there is a lot of talent that is required both on the manufacturing side. And I think Ruchir points out a very important lacuna, which is at the system level, we are going to be really confronted with a large skill shortage. And a lot of the skills we're going to need there are what I would consider very advanced vocational skills. And so the polytechnics and the ITIs that we have a very, very good ecosystem in India, they need to now start preparing programs to address the needs of the electronics industry, not just the semiconductor industry. And they are two extremely intertwined industries. Right? So yeah, I think that that is something that perhaps at Sunita's level and at the government, they can start looking at expanding what they're doing already at the engineering level into more at the advanced vocational level. In fact, if you look at what happens in in the advanced countries which have a strong manufacturing base, a lot of the talent is actually not engineering graduates. They're in the US they're at AA degrees, for example. In Europe and Japan, there are lots of vocational programs feeding these advanced skills in.
Yeah, we hear that a lot in Germany, I think, no?
Yes, Germany is a template for that. Yes, it should be a template for that. Yes.
And we actually also have templates. I mean, we have those kind of programs for the mechanical manufacturing industry. You have a lot of good programs that teach people CAD and CNC machining and those kind of things. So the general idea and the institutional framework is there. We need to put in place programs specifically for the industry that we are talking about today in this forum.
Okay. Before I ask Sunita to respond to that, Ruchir, you want to finish what you were saying?
So when I look at things, of course, India is close to me, close to my heart, and I am focusing on India. But there is another opportunity for us, I believe. And that opportunity is that this shortage of talent that we're talking about is not limited to India. The world is facing talent shortage. Some estimates that I have read that US expects a shortage of about 250,000 semiconductor engineers over the next 5 years. China, 300,000. And a small country like Taiwan is talking about 50,000 people shortage. Now, to me, that's a huge opportunity. Because if those countries cannot find talent and we can supply the talent, just imagine the amount of business that we will be able to deliver back to the world if we had that talent. So for me, this is the opportunity. Talent shortage in India, yes, but there's a talent shortage across the world that we have the opportunity and the potential to supply to.
This is work that Indians will have to go there to do, or they can do it out of India as well?
I think with lots of all the negatives that have happened in COVID, one thing that COVID has taught the world, that if there are smart people who are willing to do the work and are capable of doing the work, they can do it from anywhere. So I believe that, yes, some people might choose to go live in those countries, but there is still a humongous opportunity for people here. And my example is the Y2K that happened, right? Those jobs were created in other countries, but look at what that did to our country. So there is going to be a follow-on effect, which will be multifold.
Okay. Sunita, you're muted. Would you like to respond to that? Wide spectrum of skills required, vocational institution, ITIs. What kind of plans do you have? And then, of course, the whole manufacturing side of semiconductors. Sunita, you're muted, huh?
Sorry. So there are programs in place, the vocational skills also in the ministry, not at a very big level, but then again in the ESDM sector, short training programs are there. And yes, institutions like NILET, which is specifically for the trainings, and CDAT.
Institutions like which one, Sunita?
NILET, National Institute of Electronics, and this is for training. Electronics training. So NILET has got around maybe 40 of the country, which is a society of MIT, which is especially for the trainings. So they trainings. So in various segments of ESDM. So NILET is one which is doing the trainings, and that. But I also feel that with a sudden surge in the demand, we need to take this opportunity and start those non-formal courses also, along with the formal ones. And this has to be done, I feel, in close consultation with the industry, because sometimes the course curriculum of these vocational colleges is not in sync with what is happening or is required at present in the market. It is too, sometimes the courses of ITI or or the polytechnics, they have to be aligned with the present requirements. So I feel, yes, that this needs to be done, and we are actually addressing it from all fronts, what has to be done at all levels.
Okay. Anand and Ruchir, any specific suggestions to Sunita that this you can do, which probably they're not thinking of at the moment? Anand, any suggestions?
Anand, I'll let you go first.
Yeah, I think one suggestion is, as I actually reach out to large areas of this country in this hunt for talent. So we are sort of perhaps uniquely as a company going to a lot of, even out of the way small towns, places where there are engineering institutions to see what talent we can find. And we are always delighted that we're always finding some talent in various parts of the country. One of the things that stands out is that we have a lot of young people with interest and talent and potential who simply don't have the right information on where they can go and avail of all the programs that are out there. So for example, Sunita mentioned a few perhaps extremely good programs. I think needs to be a very serious sort of an outreach, an information outreach, so that every college in this country, whether it is offering BSc and MSc in electronics degrees, or it's offering BTechs or diplomas, that there is broad awareness of what is available for the youth to take the next step to build their talent. That is actually a very severely lacking sort of information. This is a very severely lacking information platform in this country. The great programs, the government puts them out. They are running in perhaps in cities where the government has these institutions, and even outside of government, wherever the programs are, sometimes supported by the government. The information about this is simply just surprisingly not there. There are not even, I would say, very easy to use online sort of platforms, databases where all programs are listed, deadlines are put in place, forms are available, so that students in even on their cell phones in small towns can easily avail. So I guess if you're asking me for some suggestion for Sunita, I think all these programs that are being put in place, that's great. I think you should need to somehow also invest in disseminating the information of these programs and making it easy for people to
know where to find what quickly and all that. Okay, what are the opportunities available, and these are courses they can do.
Yes. Yeah. What are the deadlines when they should apply, and the calendars of all the programs, everything consolidated in one, maybe in one website, that would actually go a long way to.
Yeah, Anand, you have put it very rightly, and that is why I think I'm here, so that I can, this is one of the ways I want to tell the people what we are doing in the government. And I also feel that, the number of programs and the immense opportunities that are available in the government in various, not only our ministry, but from DST, from CSIR, from other skill development ministries. Lots of opportunities are there which the common people are not aware of. So I also feel that we have to do this. So one of the examples that I'll just give you was that we had this microprocessor development challenge. And we have developed our own indigenous processor, Vega and Shakti. We wanted students and startups or faculty to come and develop applications around this. So we had thrown this challenge, and we were wondering, or we were thinking, how do we disseminate? As Anand has rightly pointed out, that it can be limited to a few whom we just tell or who are somewhere linked to us. But we wanted the publicity, wide publicity. So this is how we went. So we contacted AICT, put it on their website so that all the academics were there, put it at ISA so that the startups are able to see it, and then also in our mighty startup hub in the DST, DPIIT platform. So we are trying, and yes, I take your suggestion that there are a lot of programs and we need to disseminate them properly.
How many participants did you get eventually?
You'll be surprised. We got around 6,000 applications. So
okay,
we had to submit in groups. So there were around 6,000 applications, where there were around 4 or 5 in each of the applications. And we had to take only 100. So we were wondering how to, screen out so many, and we never thought. So we had to increase our team and then actually look at each and every application. So it was a very heartening and a very eye-opening experience for us. So this time when we have started the chip to startup program, again, approached AICT to disseminate this.
Oh, very good. Very good. Ruchir,
Oh, no, before I can say that I have some suggestions for the government and MIT,
Yes.
I think credit must be given where it's due. I have seen SMDP 1.0 and now SMDP 2.0, which is now C2S. It's at a different level. For the first time, I saw MIT team starting discussions with the stakeholders 2 years before anything was put out, to look at what should go in there, what makes sense. And all of that dialogue was indeed a dialogue. It was not just a one-way communication that, hey, we are doing this. So what has come out in C2S, I started talking to Sunita ji and her team almost 2 years back with some initial discussions. So credit must go there. Sunita also said that things don't happen overnight, and it will take us some time. But this C2S is, I believe, one of the biggest evidences of the right intent with the right action behind it. Now, how can we take that and take it to the next level is what essentially we should be talking about, right? So information dissemination, of course, Anand pointed out, Sunita also said that, yes, we can always do better. We are doing things, but we can always do better. I want to take it to the next level, that all these skills that we will develop, and we talk of make in India, make Atmanirbhar, right? And in the past few months or a couple of years, design-led manufacturing as a phrase has become very popular. I want to just experiment with that and change it to design-led design. Meaning, are we teaching our engineers how to design products? We are teaching them how to design IP, how to build certain things, but do we really teach them how to design? And now you can ask me, okay, give me an example of what design could be, right? So somebody makes a cell phone. Now somebody likes an iPhone, somebody likes some other Samsung phone, somebody likes a Vivo. But they're all pretty much the same. So what can India come and do in that? So just a thought experiment for you to consider. World over, except for India, there is a problem that their population is aging. All these fancy cell phones with all these billion features become increasingly difficult for senior citizens to use. Can we in India design a cell phone which is still as powerful as any of these modern phones, but is targeted specially towards senior citizens? So that's designed for use. One cell phone does not work for everyone. Even go lower in that, a TV remote. It becomes increasingly difficult to operate these things for the generation that is coming, right? I will be there very shortly. Then the second thing that we have in our DNA is this word jugaad. Now, people take it negatively, but I take it to the positive side. Can we make systems which are designed for reuse, which are designed for repurpose, which are designed for recycle, right? Because the world is going to face problems with all these electronic devices that we are making that we just talked about. If it's everywhere, after a few years, guess where it's going to end up?
Landfills.
In a landfill, right? So can we start thinking about doing that? Now, what is happening today is we have these two separate streams. There is engineering and there is design. And these two don't meet. So that would be my suggestion. Okay, let's encourage including design elements in the engineering curriculum. That's number one. Number two, when I go and talk to the professors in colleges, and I have talked to professors in all our tier 1 colleges, tier 2 colleges, and tier 3 colleges, I see that the hunger to do something more is pretty much the same everywhere. What's different is how the college and the students are measured. So if a student, so let's say, I want to take somebody as an intern, and I want the intern to be with me for 9 months. At the end of 9 months, I have an expectation of teaching the student and making the student hireable either for me or somebody else in the industry. What expectation does the college have? Do they have an expectation of a publication? Because private companies will not allow publications to have our private IP to be put out in public. And that creates a little bit of friction. So how about if we create some incentives for professors to allow students to go into internships and become industry ready? How about measuring the school and the professors, not just on publications, but how many engineers were they able to place into internships? How many interns got hired? So some different mechanisms. The third thing is, and I have to be very careful when I say this, and I'm trying to be very, very careful. Our faculty by and large is very good, but the context that they operate in is different. In tier 1 schools, they have a lot of exposure, they have a lot of autonomy, and they can devise programs based on what they believe is going on in the industry. On the other side, we have deemed universities or autonomous universities who also have the flexibility to move and model their curriculum based on what the industry needs. There is this chunk in the middle who are tied with universities and the set curricula that the university has defined. And the professors, despite their desire, the students, despite their desire, have to comply with what is required to get a university degree. So let's start looking at that as well. If we can give some autonomy to all the colleges so that they can have some deviation. I'm not saying it's a free for all, but give freedom to go and experiment.
Sunita, you want to respond to those 3 points Ruchir mentioned?
Yes, I think, yes, you have touched on some subject which is very close to my heart. What that was, when we started the earlier, I'll again come to our SMDP program. When we started it in 2014, the earlier phase, so the name was Chip 2 Systems. So with the same intent that we have designers, we have the designer or the students going to the multinationals, but they are doing very focused jobs there. Someone is in validation, they will just be focused on that. Someone is in back-end physical design, they are doing just that, or someone with front end. Nobody is thinking in terms of systems. In our country, I thought that why are we always making chips for outside countries? Why don't we have system developers here?
Yes.
For whom we can build our systems. So this has to start with the thought process from the educational institutes itself, where the students are trained to think about the systems as a whole, not as just one portion of the design in a chip. So this is what our intent was, where we had this hub and spoke model, where we had the tier 2, tier 3 colleges with a mentor from IIT, premium institutions. And there the faculty and the students were asked in a cluster mode to take one system of their choice, develop it, design it with the ICs or the IPs for each of the sub-modules coming and integrating it into a system. So that was just one effort that we had tried, where we had come out with SERDES chip from IT Kharagpur. Then we had an LCA control system for the LCA that was done along with Bell by ISC cluster. The whole cluster where NIT Trichy was there, where NIT Warangal and Suratkal, so NIT Puducherry, so on NIT Calicut. So there were different 10 systems which were taken. One was an endoscopy capsule which can go inside the system and intestine and look at the give the parameters to the doctors. So the endoscopy capsule has actually been designed. The fab has been fabricated by IIT Delhi and its cluster, which includes NIT Uttarakhand, NIT Jalandhar, then NIT Goa. So mentoring of them. So it is not something which will go into a commercial market, but it is something in which the students and the faculty are forced to think in terms of design systems. So that is what we had started. And I think this needs to be continued. It should not be stopped. So we are trying that we take it to the next step. So yes, you have rightly pointed out that we should look at systems and the frugal solutions. So this time we are trying to see whether we can bring industry and academia close together with a startup also contributing, where there are some innovative ideas which can come. We are funding the startups also for any frugal solution, for any solution that they can have, and taking it to market with the help of industry. So is this whole, if we look at the manpower or upskilling or skilling, it has to be in totality. So I saw some institutions like NIT Mizoram, where you were talking about tier 2, tier 3 colleges. They had first time taped out designs, and where, in the first attempt they did not even put the pads, they did not know that what fabrication involves. So that is a type of nurturing or the mentoring that we have been looking at, and this time in this phase they are trying to take an ESIC which with an industry participation. So that is one really some I'll say improvement in their expertise. That is one. And yes, I think faculty, yes, should be given autonomy. That I think is missing in tier 2, tier 3 colleges. And what we had faced during this implementation of our previous phase, where there were 60 institutions, most of the faculty in the tier 2, tier 3 colleges are on contract basis. And I'm talking about most of the government institutions. We did not have much participation of private institutions. So even the regularization, because if we want the progressive improvement of the quality of the faculty, they have to be regular. They cannot be on a contractual basis, and that too in an engineering college. I feel that needs to be taken care of, and we had written to the directors also, and they had their own challenges in recruitment. But yes, that autonomy has to be there, and some incentivization for the faculty is there when we give them, this R&D project. So that adds on to their promotion chances, and in a way it is a win-win situation for us as well as for them, that we are trying to train the faculty and they are also getting a career progression in return.
Yeah, well, what internships? Can you push them to send students for internships and all that?
Yes. So yeah. So in the internships also, I've seen that tier 2, tier 3 colleges were very keen on sending the interns for our program, the SMDP program, where we had a couple of companies which were associated, Intel and NXP were there. So we were sending the tier 2, tier 3 students to Intel and NXP, where they got the PPOs also based on their performances. And there were around 50 interns which were selected through the earlier phase. And otherwise, they would not have been getting that exposure, or the companies would not have come to those colleges. So, so that was there. But then what I also feel is that what Richard had also said, that there is a little, I'll say, the faculty is a little conservative in sending the students because they are not allowed to publish. So I think there has to be publish whatever they are doing during the internship in the companies. So I think there we need to chalk out a program, and some understanding has to be there that the students are given the opportunity of internship in the companies, but at the same time some faculty also benefits out of it.
Yeah, I'm sure
they are given some incentives in terms of recognition for their career progression if they send students back for internship or for trainings.
Okay. Yeah, Ruchir had made the interesting point in the previous conversation that you get 80% of your employees from tier 2 and tier 3 institutions. Is that what you said, Ruchir?
Yes, you're absolutely right. You're absolutely right. And I would surmise that it's not just me in my company. 80% of the demand in our industry is probably being met by students from tier 2 and tier 3.
Okay.
And I still include NITs in tier 1, Sunita. So that for me, that's still tier 1. So when I say tier 2, I am excluding IITs and NITs.
Okay.
So that's my thing. Maybe industry across industries 60% or 85%. But for my needs, my experience is 80% is tier 2.
Yeah, Anand, is that similar for you?
That's very much. I would say more than 80% of
Really?
our intake is tier 3.
Okay.
Yeah.
And which streams do you hire from?
So we hire from ECE mainly, but we are trying to cast a wide net in general. So we've been, we also assess potential of students from, say, electrical engineering. We started reaching out to even MSc electronics students. We've been assessing diploma students for certain positions in our company. So as the struggle for talent is
becoming more intense,
whoever casts a wider net is going to
get more.
That's what we are doing.
So I also feel that because the tier 1 colleges, if you see the top students, they are generally not sticking to their area of expertise. Somehow they are shifting to finance or to any other. I see ECE students going for coding and for
software is grabbing everybody.
Software.
Yes. So somehow we have to get them back and hold their interest. That is also one concentrated effort that we need to do.
Absolutely right, Sundarji. I think that's, sorry, go ahead. I spoke over you. Absolutely right. And that's where I think the industry has not done its part. The best kept secret for our industry is that the average starting salary for a college grad in electronics is 2 to 3x higher than average starting salary in software.
Exactly. I mean, that's what I also thought.
And I don't know why we keep it so close to our heart and we don't push it out. So what that does is that there is some sense of misplaced glamour or misplaced lack of glamour with our industry, and we need to do a better job. And yes, we also need to make a couple of unicorns. And as soon as we do that, the draw will come, and people, even though they graduate with a computer engineering degree or an electronics degree, won't switch because they will see a better future for themselves in our industry. So we need to do a better job as well.
Right.
A lot of questions coming in, Shilpa.
Yeah, there's a question similar to what Ruchir said just now. This is from Mohan Suri. Can the electronics industry grow its employment opportunities to the scale of the IT industry? What would be your message to electronics students who are deciding between pursuing a career in electronics versus IT?
Anand, Ruchir, what do you have to say?
There is a similar question on the chat as well that just got posted that I can see. There is somebody who's asking that, hey, I'm planning to do a master's. Would I have more prospects in choosing VLSI or control systems? So there is some overlap. Anand, you want to go take a stab at it?
Yeah, I would say that first of all, we need to recognize that software is a very broad term, and in the VLSI industry, coding is a very critical skill. In fact, I would say it's the most critical skill. If people are good coders, we can make them good designers. So this dichotomy between software and design, chip design, that dichotomy really is not real. You cannot be a good designer in the semiconductor industry without having really good coding skills. So that's point number one. Other thing I would like to say, just going back to a few of the previous points, I think in the primary agenda in the university is to excel in pedagogy. I feel that we really need to focus on delivering good learning outcomes. So we have to be a little bit cautious when we talk about universities creating products, taping out chips. We have to be conscious whether the learning outcomes are there or not, because really what we need are a lot of people coming out with excellent understanding and skills and knowledge, as opposed to having created products necessarily. I think it's a good thing. I mean, creating products can deliver a good learning outcome, but it's the learning outcome that we should not lose sight of at the college. College students are in the 18 to 22 age group. They've got the rest of their life to do great things. They really need to be well prepared, and that focus we should not waver in that. I sometimes get a little bit concerned as I reach out to colleges that there is a little bit of focus shifting from pedagogy to incubation centers, startups, entrepreneurship, and all that kind of thing. So we should be a little bit cautious there. They all have the room, but we shouldn't go overboard. Is my point. So then coming back to what people, there's some of the questions on the chat session. I think it's very important that all engineers come out with good coding skills. That's not because they will necessarily be coding a lot, but that actually is a way, it establishes a cognitive process that we value in our industry, if you can think like that, and we even need those skills always. Then I think we need a lot more general exposure to compute environments and IT. We see a lot of students who join us. It just takes us a long time, even before they get to doing chip design, just getting familiar with the tools of the trade in our industry. Unix as an operating system and an environment, it's universally used. We see very, very few students who had any exposure to that. Very different from what you would see for for students in the US or even in South Korea and places like that. So we need to kind of get people a lot more exposure in the colleges. These are very low-hanging fruits that if we do that, it would actually give people a very serious leg up when they join us. So I think there are things like this, giving access to compute environments. Today, most of the tier 2 and tier 3 colleges, if the student is outside the college, that student has no access to a compute environment. They're basically restricted to the cell phone, or they're on their Windows laptop, browsing. They have to go to campus to actually access an EDA tool or even just a simple compute environment. Whereas every university that I know of, forget about the developed world, but even in some of the Asian countries, students have easy access to their university compute environment from their homes. This is amazingly, it's amazingly impactful when you enable that to happen. People are surprised when I say in India, outside of the IITs, students, the lakhs of students that we have in engineering colleges, they're outside the college, they just have no access to compute environments. So these are some of the very low-hanging fruits. I think these are kind of things that maybe Sunita can address very quickly. And I think the dividends that we get will be very high from that. And the students who are asking what they should do, well, they should focus on coding, get a lot of exposure to compute environments, and basically learn the foundations of electronics. That's what we are looking for when we are looking for people, when we are looking to hire people.
So Shilpa, I'll give a very simple example. I'm not a career counselor, but something that touches us every day, which might address this question. First of all, IT is a catch-all phrase. It catches everything that has anything to do with compute, whether it is software-based compute or hardware-based compute. So the question that I would ask is that, hey, if somebody wants to be an actor, would they choose to work on the TV platform or in movies? There are many more avenues available on TV than in the movies. But think of it, how many superstars do we know who have limited themselves to the TV platform, whether it's OTT or any other channel affiliation? So I consider VLSI and hardware and electronics as a field where people can really become superstars.
Yeah. Absolutely. Control systems is used in what, for my understanding?
Control systems is the ability to control systems. I mean, essentially, I'm not trying to be silly here, but the ability to decide how an actuator should move, when it should start, when it should stop, should it go backward, should it go forward. This is essentially control system theory. It goes back to basic electrical engineering, where we had motors that moved parts back and forth. Okay. Now, a lot of that is now moving to electronics, but simple thing, a CNC machine. How much should it get the actuator in to start cutting something? When should it stop? That is all basic control systems. Then there is, different there's a whole branch of electrical engineering that deals with control systems. But I will go back to saying that if you want to be a superstar, if you believe you have what it takes to be a superstar, stick with VLSI. The industry will make you one.
Yeah, just to tell you, Sujit, we are also doing R&D in control systems. So the automation, industrial automation or the system design automation. So that essentially uses a lot of control systems. The EV program that we have, so that also has R&D for controllers, motors, battery management systems. So
Okay.
systems also has lots of avenues, and where the industry 4.0 and automation coming in, those control systems are an inherent part of it.
Okay.
That is correct. As the electric vehicle ecosystem gets built out, a lot of key sectors that we are now entering are sectors which will need people well skilled in control systems.
Okay.
Yeah, I think both the areas are have a lot of promise from a career and job standpoint.
Sunita, this point that Anand was making, the university allowing students to access their compute resources from anywhere.
Yes.
What do you think? What will that
Yes.
require?
So yes, so I'll come again to our C2S, Chip to Startup program, where we are this time. So Ruchir knows about it, he's part of it, that we are giving access to the EDA tools, the Mentor, Synopsys, and Cadence, all of them, 3 of them. And instead of the licenses being physically located in the institutions, so we are giving remote access to the licenses. So it will be on one server. This time we have identified CDAC Bangalore as one of the nodal agency where all the licenses will be housed. And the access of the licenses, although the binary files have to be in the institution, the access will be given to anyone who is sitting anywhere, because this is again thanks to the COVID scenario where the students were not able to access the labs. So we started this as a pilot program in the previous one. And in this phase of the Chip to Startup, we will be going for the remote access of licenses where the student sitting at home also can access the licenses, do his design and complete any simulations or anything that is possible.
Excellent.
And regarding the compute also, we are still considering it, giving access to since the National Supercomputing Mission is with me. So in fact, it's just transferring the resources from here to there. So I am also thinking about whether to make accessible some compute from our HPC resources for this scheme, for this program, C2S program, where the students actually can have access. Generally, the workstations are there in the colleges, but yes, from home it has to be there. But then but for the licenses, there might be some maybe constraint, because the licenses should not be misused by anyone, because these are just academic bundles. So we have to ensure that these are used only by the students or not by some commercial entities. So those all constraints will be there. Besides that, for the compute, I think we are just working on that, whether we'll be able to give access to the compute or not. So I think, yes, that is possible.
Okay. Anand, that kind of answers your question, I think, no?
Yeah,
the issue that you raised. Good. Yeah. Shilpa?
One of the things that I had said, right, the SMDP 1.0 and C2S, it's on a different plane, different level. And this is just one element in how it is different from whatever has been done in the past. In SMDP, when we 1.0, when we participated, our teams had to go to several institutes individually, talk to professors, and get our solutions into the school, and then try to influence the curricula and the usage of it. Now, as suppliers of technology that will eventually become useful for electronics, this platform now allows us to do this once and focus our energy where it should be really spent on is making the student better, not just getting access to the student. Right? So now our energies will be focused on making the student better instead of focusing on all the logistics that were involved in getting access to it. So, this is something that I really want to thank MIT for, because this new setup is the catalyst. I believe that we need it. That will change things.
Thank you.
Excellent. Shilpa?
Yeah.
We have this question from Vaibhav Kumar. Most of the top talent focused on electronics within tier one colleges happens to be going abroad for an MS or PhD. Do you think the Indian ecosystem would be better off with such talent working in India?
Sure, it will be. Who wants to take us?
So while it is true that a lot of us, people from, students from amongst us do go to opportunities which they believe are better for them, I would say that over the last 10, 15 years, that number has shrunk significantly. Because people are realizing and students are realizing that there are enough opportunities to lead the same good life in this area if they are in this industry and keep all their family ties and do all the things that they were able to do with being employed here. There's always going to be a section of society who wants to look at a different direction, want to see a new horizon and explore the horizon. And it is not limited to just tier 1 colleges or tier 3 colleges. It depends on the individual. But just look at, Anand and I, right? We both spent significant amount of time and we came back because we thought this was better. We made a conscious choice to come back. And so I'm not worried about people going to explore, whatever the extent of exploration that they want to do. In any case, it helps our country, because if they go out and learn something new, they will teach somebody what they have learned. So we get the benefit regardless.
Yeah. To all three of you, any specific messages to students? What should they learn? Where should they learn from? I mean, of course, you can go to college, but outside colleges and all that, what can they do that can get them jobs in your industry? Any advice that you can give? Sunita, you want to start?
Okay, yeah. So I think that I'm okay. No, I'm being very optimistic, and I because we ministry has launched a scheme. The government has launched a scheme with 76,000 crore, which will give ample opportunities for the students, especially to participate, and ample opportunities of employment in this. And I feel that in India, what Ruchir had said, I'm just complimenting it, that India is at a very nascent stage where the opportunities are, in an exponential term can increase. If we look at other countries, they are at a much higher or technologically or advanced stage. So the opportunity to grow along with India is immense for the students also. And I feel they have also the freedom to choose the areas that they want to work depending on their interest. There is no dearth of employment opportunities, or depending, it's not that, okay, there are very less employment in this area, I cannot go there, or more there, or the pay scale may be more in some areas. So that is the opportunity, I think, is right here at the threshold, and I think they should be able to grab that. And I think government is open, and from the government side, and we are trying to put our best foot forward with the industry and the academia to give the most to our youngsters, because you are our future. So that we become the best and the global leaders in what we have, because our students, our youth is our strength. So we want to nurture it in the best way possible, and giving all the opportunities that we can. We are open to ideas.
Okay. Anand, any advice?
Yeah, so I think what Sunita says is very correct about the opportunities that are there in this country. To me, it's just astonishing just seeing the transformation in opportunity in India in literally the last 5-7 years. And so jobs are plentiful. Companies are looking for talent. It is unprecedented how much the opportunity is. So what can students do to get in? I think I would have some very nitty-gritty suggestions. As I said earlier, get good at a few things. Get good at coding. Get good at electronic design. there is a lot of learning content available and readily accessible. But all the learning content in the world can be there. If you don't spend time struggling to absorb it, it's not easy. These things require you to focus, spend time, and get good at things. Do that. Sunita mentioned a lot of programs that the government is putting out. I know there's the NPTEL content that is there that India has got. There's all the MOOCs that are there from global MOOCs. There's just an astonishing amount of excellent content. I've seen it myself. It's top class, easy to digest, but nothing in learning is easy. That's why these are well-paid jobs, because you're going to have to spend effort and learn. I think that's my message to students. Content is there, jobs are there. You have to absorb that content and put out in GitHub and other platforms the things that you've done, so that the industry can see that you're doing things. If you do that, the opportunities are there, and I think the career prospects are amazing in India right now.
Ruchir?
Anand had some awesome ideas, and he used the term nitty-gritty. Let me go one level even lower than that in the detail. First thing I would ask the students to do is to reduce this tendency to only learn how to answer the what and the how question. Start asking the why question. Why am I being asked this question? Why is this a problem? So that's number one. That's a mindset issue. Then the second thing is, go talk to your professors and say, hey, are we part of this C2S program? If you're not, why not? And what will it take for our college to become part of the C2S program? And for some reason, if you cannot become a part of the C2S program, talk to your professors, okay, what is happening there that we cannot do, and why can we not do it? Now, there may be other many reasons why it's not possible for them to get into C2S, but all of that is done. Then Anand talked about MOOCs, all these open programs that are out there that the students can go and learn from. I believe the best place to learn electronic design is to go to EDA suppliers. We have a lot of free content available on our website. So any student can go to Siemens EDA website.
Okay.
And while we are putting out a module to teach one of our solutions, it also talks about why this solution is needed. Why are you going to use it? What was the problem that was defined, given to you? Why do you have to solve it? Why is it a problem? So in that case, the students not only learn the tooling part, the vocational part that Anand was talking about, but they also learn why is it important to do this. So
what qualification do you require to do that, your course?
All of this, a lot of this content is free, Sujit. There is no qualification required. All we ask for is an email address. That's it. And I'm sure my competitors have similar programs on their websites.
Any science student should be able to.
Anyone can do it. We are not asking for any qualification. This is just learning that we have put out there. Second, if for some reason they cannot get into C2S and they have exhausted what's available for free, go talk to the college management and say, please, can we get some EDA tool? Go talk to this vendor or go to that supplier and ask pressurize the college to get this, because at the end of the day, as students, it's your future that you're talking about. The faculty will be there, the college management will be there. You are the one who's going to go in and come out and then take the next step. So don't hold back. Keep pushing your college, keep pushing yourself. And like Anand said, the opportunities are, I don't want to use the word unlimited, because nothing is ever unlimited, but there is more room than what we have supply coming in. It's just that how do you differentiate yourself from the average? And that's the only way, I think, is by asking questions and applying reverse pressure. So that would be my suggestion.
And you're coming up, I know you can't provide the details yet, but you're coming up with a platform to an industry platform or something.
Okay. Yeah.
Right?
Yes. So now I have to wear my IESA, the India Electronics Semiconductors Association hat. And while I cannot divulge the details, but we are working on a program where we will have some sort of a certification that we will be offering to students, where students can come in and look at the program that we offer, go through that program, which will be delivered professionally. And at the end of the program, there is a certificate. so that when somebody comes out, a student comes out with that certificate on the resume, somebody like an Anand, somebody like a me has two resumes, one with the stamp, one without the stamp. Guess what we're going to choose? And this is essentially a learning that the association got, because Siemens EDA, we started doing a certification of our own. We have training programs for a fee, nominal fee, depending on whether it's for a student or a large commercial establishment. The fee structure varies. Very affordable, where students can come in and do this training on their own. They have a test at the end of it, and they get a certificate with a stamp, which they can put on their LinkedIn profiles, which they can put on their CVs. Stamp by itself is not very useful, but what it does is that it tells Anand and me that if I have 5 candidates and 2 of them have these certificates, I'll talk to them first. So Sujit, thank you for highlighting that. I was not going to talk about it because IESA is going to make a big announcement very shortly, and we will wait for that. But it's coming. It's coming.
Okay.
So, Sujit, if I may just add on to what Ruchir had said. So yes, it should be the other way around. The student should go and ask their profs if they're part of the C2S or not. The C2S is open. The applications are open till 28th of Feb. So they can apply, any institution can apply there. So it's open to all of them. So there is an eligibility criteria and different categories in which they can apply. So I think that is a wonderful opportunity for getting the tools and the exposure to the actual design cycle, the full design cycle. Plus, we also have a training program, especially for students under Chip to Startup, where NILET is taking this program. It will be training for, so 1 lakh students are targeted to be trained in this. So it is not just limited to the C2S institutions. It is open to everyone, to all the institutions. Even there is a credit which is associated with each of these programs. Some of them are NSQF compliant, some certifications are there, and some credits for the courses are there. So it will be an opportunity which is be given to the students apart from the C2S program if they are not able to be part of this. So that is a separate opportunity, although it is part of this, but others can also apply. Other students can apply.
Okay, wonderful.
We
yes.
And we also have R&D program here in the where the academia can come for support, where EDA tools and all the other opportunities will be given through the R&D projects that can be taken by the academic institutions, and students can be part of that.
Okay. Great programs. We are 8 minutes past deadline. Great discussion, but yeah, absolutely. Like Sunita said, 76,000 crore program announced for semiconductors. Prior to that, a lot of programs announced for electronics. So this industry, which for a long time people thought was not taking off in India, looks set for a big takeoff. So lots of job opportunities likely to emerge. And like Sunita, Anand, and Ruchir, all of them said, for students, for young professionals, plenty of opportunities that you can grab, plenty of online resources available, a big certification program that IESA is set to launch. So grab those opportunities, the C2S program that Sunita and others have been talking about. So grab those opportunities, and I'm sure there can be a great career ahead of you for all of you. Yeah. Thank you so much, Sunita, Anand, Ruchir. Thanks from Shilpa and me. Nice having you.
Thank you so much. Pleasure.
Thank you.
Okay. Bye.
Bye.
Bye.